Hey guys, I'm going to walk you through some of the problems for today, and then whenever we don't go through in the video, you're going to finish for homework. So to start, pause the video and try the do now, and then when you've got it, play the video and you can check your answer. Okay, so for the do now, you should have that x equals 5 and x equals 1. So moving down to the theorem, we're going to keep talking about proportions in similar right triangles. So the theorem for today is the altitude to the hypotenuse of a right triangle separates the hypotenuse so that the length of each leg is the mean proportional between the adjacent hypotenuse segment and the whole hypotenuse. So what that means is, like we talked about yesterday, we know that these triangles are similar. We know that A, C, B is similar to A, C, D because of angle, angle. So since we know that those triangles are similar, we can set up a proportion using their side lengths. And the ones that we'll focus on today are going to be the hypotenuse, one leg, which is going to show up twice in the proportion, and then one segment. So now let's look at where those pieces are on the triangle. So the hypotenuse is going to be AB. Leg 1 is going to be the leg of the big right triangle. That's what's going to show up twice in the proportion. And then segment 1 is going to be the adjacent hypotenuse segment, which will be right here, AD. That's going to be our proportion for today, and we can abbreviate this one like we abbreviated yesterday with Hlls or Hlls. This proportion also works for the other triangle in the diagram. Let's take a look at that. Since triangle CDB and triangle ACB are also similar, we'll be able to set up a proportion using their corresponding sides. And that will look like our height, our other leg, and the other adjacent segment. Okay, and that will also use the Hlls proportion. So height over leg 2 is equal to leg 2 over segment 2. Okay, so let's try a problem using this. In number 1, in the diagram below of right triangle ACB, altitude CD is drawn to hypotenuse AB. If AB is 36 and AC is 12, what's the length of AD? So we want to find this segment. So using Hlls, we'll need the hypotenuse, leg 1, leg 1 again, and segment 1. The proportion is going to look like 36 over 12 equals 12 over x. Take a second, pause the video, cross multiply, and see what you get. So after you cross multiply, you should get 36x equals 144, and then after dividing, you should get x equals 4. Notice how this problem doesn't have a value for the length of the altitude. That's where it's different from yesterday. Yesterday we were working with proportions where we knew the length of the altitude, and today we're working with proportions where we know the length of one of the legs of the big right triangle, that 12 there. Okay, that'll be the big difference between when we use Hlls and when we use SAS from yesterday. Let's try another one. So for number 2, in right triangle ABC shown below, We have an altitude BD, which we have to have an altitude for these problems to create the two similar triangles. But again, we're not going to have a side length for that altitude. So the altitude is drawn to hypotenuse AC. If AD is 8 and DC is 10, determine and state the length of AB. So that's going to be one of the legs. Okay, so we know we're going to use Hlls, so we have the hypotenuse, leg 1, and segment 1. Take a second, pause the video, and try and set up the proportion on your own. Okay, so your proportion should look like 18 over x equals x over 8. Notice how to get the hypotenuse we had to add 8 and 10 to get the full length of AC. Okay, and then we're missing x, but we want to use the adjacent segment of the hypotenuse, so that has to be 8, not 10. Okay, pause the video, try and solve it, and come back. Okay, you should get that the length of AB equals 12 after you cross multiply. Okay, we'll do one more together, and then the rest you're going to finish in class and for homework. So looking at number 3, we have a given diagram. We have an altitude creating 3 similar triangles, and we want to solve for x in simplest radical form. So pause the video, set up the proportion, and then come back. Okay, so your proportion should look like 8 over x equals x over 3. So take a second now, pause the video, and go ahead and solve. Okay, after you cross multiply, you should get x equals 2 radical 6, leaving in simplest radical form. Okay, so from here, I'd like you to finish the rest of the packet in class. If you want to work with your partners, you can. And then anything you don't finish now will be for homework, and we'll go over this tomorrow. Okay?